Let's just jump right in, shall we? Welcome to this explainer on the mechanics of memory. Over the course of this material, we're going to uncover exactly how our brains hold on to information, why they let it slip away, and crucially, how we can use that exact knowledge to become much sharper clinical problem solvers. This is specifically geared toward those of you in the thick of clinical practice and radiography training. So let's explore this together, figure out how to actually diagnose our memory failures, and look at some incredibly practical solutions.
But first, you gotta be honest with me. Have you ever frantically copied a friend's notes, just hoping that somehow, maybe through sheer willpower or, I don't know, scientific osmosis, the information would just magically absorb into your brain? And then you sit down for the exam, or worse, you're standing right in front of a patient and complete blank? Your complex anatomy is just totally gone. Look, we have all been there, but that highly stressful moment really highlights the massive difference between true active memory formation and just passively staring at a bunch of medical notes.
So here is our game plan for today. 1. The mechanics of memory. 2. Types of memory. 3. Theories of forgetting. 4. Clinical problem solving. And 5. Memory improvement strategies. All right, part 1. The mechanics of memory. The biggest thing to grasp right out of the gate is that memory is a highly active sequential process. It's not a passive filing cabinet. It actually happens in 3 very distinct steps. Step 1 is encoding. This is where you translate information into a format your brain can actually process, like when you're first getting the hang of the physical nuances of patient positioning. Step 2 is storage. That's keeping the encoded information locked away for later use, like retaining all those dense anatomy notes from lecture. And then step 3 is retrieval. This is recalling that stored info precisely when you need it. Think of pulling the correct exposure factors from your brain during a live clinical scenario. And here's the catch. If any single one of these steps breaks down, the whole memory fails.
So let's test that out real quick. What process helps information enter memory in the very first place? Is it A, retrieval, B, encoding, C, sleeping in class, or D, forgetting anatomy? Well, it's absolutely B, encoding. And hey, while sleeping in class might feel amazing, it is definitely not going to help you encode a single thing.
Moving right along, let's jump into section 2, types of memory, because not all memories have the same shelf life.
Take a look at how long different types of information actually stick around. Up at the top, sensory memory. This holds info for literally just a few seconds. Boom, it's gone. Then you have short-term memory. This temporarily holds whatever you're actively thinking about, but only for about 20 to 30 seconds. A classic clinical example here would be holding a patient's name in your head just long enough to call them in from the waiting room. And finally, long-term memory. This is what you're aiming for when you study. It stores things from days to years. This is where you permanently park your complex radiography procedures. Time for another quick check. Which memory lasts the longest? A. Sensory. B. Short-term. C. Long-term. Or D. Memory after night duty. The answer is obviously C. Long-term memory. Though I know that brain fog after a 12-hour night shift makes it feel like option D is the real answer.
Okay, section 3, theories of forgetting. Now that we know how it works, why does it break?
It's really interesting how the research distinguishes between 2 super frustrating phenomenons, retroactive and proactive interference. Basically, the more similar 2 things are, the more likely they are to crash into each other in your brain. Retroactive interference is when newly acquired information blocks old memories. Imagine you just learned a brand new radiography positioning technique, and suddenly you completely blank on the one you learned last month. Proactive interference is the total opposite. That's when old information makes it practically impossible to lock in new memories.
Then you have trace decay theory. This one suggests that physical and neurochemical changes in your brain create a literal memory trace. But if you don't use it, that chemical trace simply fades away. Think about your ultrasound protocols. If you take a long break from the clinic and don't rehearse them, the trace decays. Use it or lose it isn't just a saying. It's a biological reality.
And that ties perfectly into retrieval failure in cue-dependent theory. Sometimes you did everything right. The memory made it to long-term storage, it's in there, but you just can't get to it because you're missing the specific cue from when it was encoded. It's like suddenly remembering a first date only when you smell the exact cologne or perfume they were wearing. That scent is the key that unlocks the storage.
We also have to talk about the organic, biological causes of forgetting, which usually come from trauma like a stroke. This gives us 2 types of amnesia. Anterograde amnesia blocks the ability to form any new memories after the brain damage happens. Retrograde amnesia, and just think retro for backwards, is the loss of memories from before the damage occurred.
And here is a pretty sobering statistic. 1 in 10. We see organic memory loss in degenerative diseases. And Alzheimer's, which is the most common cause of dementia, affects 1 in 10 people over the age of 65. It's a progressive disease that starts by wiping out recent events and eventually leads to severe confusion.
All right, last check on forgetting. When new info blocks old memories, what do we call it? A. Decay. B. Retrieval failure. C. Retroactive interference. Or D. Panic. If you said C. Retroactive interference, spot on. Though, again, D. Absolute panic during a practical exam is a very real distractor that will definitely tank your recall.
Let's pivot now to Section 4, Clinical Problem Solving, because keeping the knowledge is only half the battle. You have to actively use it on the ward.
Solving problems in a hospital isn't just guessing. It's a systematic 6-step process. First, identify and define the problem. Do not mess this up because if you identify the wrong source, every step after this is useless. Second, form a strategy. Third, organize your info. What do you know versus what are you missing? Fourth, allocate your resources. Fifth, monitor your progress. And sixth, evaluate the results to see if your fix actually worked.
But human brains are stubborn, and things get in the way. A huge obstacle is functional fixedness. This is our tendency to only view problems in the most traditional, customary way. If you get locked into that mindset, you become completely blind to alternative, and maybe even better, clinical solutions.
Very closely related to that is a mental set. This is relying entirely on solutions that worked in the past. Now, sometimes that's great. It's a handy shortcut when the ward is busy. But over-rely on it, and it causes cognitive inflexibility. You get stuck in a rut and miss out on innovative fixes for unique patient cases.
So, to sum that up, if you want to be a top-tier clinical problem solver, guard against these 4 traps: making blind assumptions, functional fixedness, mental sets, and getting bogged down by irrelevant information. When a medical case is complex, it is way too easy to get distracted by data that just doesn't matter. All right, we know the problems. Let's finish with the cure. Section 5, Memory Improvement Strategies. Here is your rapid-fire prescription for better studying. Repetition fights decay. Grouping information organizes your storage. Attaching real meaning builds incredibly strong retrieval cues. And writing your own notes forces you to actively encode. Just remember, active engagement is quite literally the only proven cure for memory decay.
Honestly, get a little weird with it. Make up ridiculous anatomy songs. Build wild mnemonics for the cranial nerves. One of the absolute best things you can do? Stand up and pretend you are the expert teaching your study group. Forcing yourself to explain the material out loud is a massively powerful way to lock it into your own long-term memory.
Which brings me to one final question for you. Knowing everything we just talked about, are you going to go back to just staring at a textbook and praying for osmosis? Or are you finally ready to actively encode, store, and retrieve your way to clinical success? The choice is entirely up to your brain. Thanks so much for hanging out with me for this explainer. Now get out there and make those memories stick.